ladies and gentlemen.
Let's talk graphs of lines. So the standard coordinate plane, also known as the Cartesian plane, also known as the rectangular plane, is where you have a perpendicular line set between an x-axis, which is horizontal, and a vertical axis, which is the y-axis. So x-axis, horizontal, y-axis, vertical, intersecting at 90 degrees perpendicularly. So every increment determines up and to the right determines your point. So for example, if I have a point at 4, 5, it means that I went 4 right and up 5. Negatives is just reverse of up and right, which would be left and down. The 4 is right and the 5 is up. There we go. So if we talk about lines, which is big idea right now, we have slope-intercept form. It is the simplest form to write lines in. It is the form y equals ax plus b. You may also be familiar with y equals mx plus b. Same idea. The b gives you the y-intercept, and a is the average rate of change of the line, also known as the slope. So slope is the a value, which is rise over run, the amount up over the amount right, the change in elevation over the change in horizontal distance, change in y's over the change in x's, or y1 minus y2 over x1 minus x2, or you can flip those around. You can have y2 minus y1 over x2 minus x1, as long as your points are consistent. It doesn't matter which order they're in. So let's answer a question. Which of the following could be an accurate graph of y equals 1/3 x minus 4? Well, first and foremost, y equals ax plus b. Our y-intercept is -4, and our slope is 1/3. So 1, it's increasing. Positive rate of change, it's going up. So it cannot be b, and it cannot be d. Both of those are decreasing. They're going down over time. Now we need to look at our points here and see what's actually happening. I see that this one crosses at -2, and this one crosses at -4. So this one cannot be it. It is this one. It crosses at -4 and goes up 1 for every 3 that it goes right. Not too bad, right? Now, parallel and perpendicular is an idea of if I graph more than one line on the same plane, do they intersect? Do they never intersect? Or do they cross at exactly 90 degrees? It doesn't matter how we oriented it. Do they cross at 90 degrees? And the way to tell is you look at their slopes. If we have the same slope, like 2/3 and 2/3, those would be parallel. But if we have opposite reciprocals, meaning if one is positive, the other one is negative, and the fraction is flipped, so 2/3 would be 3/2, those would be perpendicular. Anything else, and they intersect once, just not at 90 degrees, so it's neither parallel nor perpendicular. So the easiest way to go about this, or one way to go about this, would be to solve the equations you have for y and get it into the y equals ax plus b form. So if I look at the first one here, I can rewrite it over here. 2x plus 3y equals 4. If I subtract 2x from both sides, I would have 3y is equal to -2x plus 4. Then I can divide by 3, divide by 3. Now I'm going to distribute my division on the right-hand side. Y is equal to -2/3 plus 4/3. Now the b doesn't really matter for this question. Let's solve this one now. So I'm going to add 4x to both sides. I get -6y is equal to 4x plus 11. and then we'll divide by -6, divide by -6. Again, we're going to distribute our division, and we are left with y is equal to, if we simplify, -2/3 plus, oh no, minus 11/6. Oof, I'm messing up twice. 11/6. If we compare the slopes, I'm also missing my x. Oof. Slope here is -2/3. Slope here is negative. Oh, I'm missing it over here too. Oof. Slope is -2/3 for both. They are parallel because the slope is the same. Don't be like me. Don't forget your x's. But take it one step at a time. They're not too bad. Average rate of change, rise over run, change in vertical over change in horizontal, and then parallel, same slope, perpendicular, opposite reciprocals intersecting at 90 degrees. Good luck. If you have any questions, let me know. Otherwise, I'll see you in the next video.